Hi, and welcome to the video on the average atomic mass exploration that is due on Thursday, February 11th. So first of all, to access we're in Unit 1, Week 2. We did this on Tuesday, so it'll be in your Tuesday folder. And here it is. You would open it up, average atomic mass exploration. So the first thing you want to do, and I'm going to go to my copy because if I go to the original, it'll disturb your document. When first thing you want to do is read through the instructions. Even though I'm going over it with you, it's always a good idea to read it yourself. All right, after reading the instructions, you'll notice there are 3 parts: Part A, Part B, Part C. All of them use this FET link, so you want to open that up. And the first thing we're going to do for Part A is use the isotopes FET link. Okay, so in this part, the purpose of Part A is for you to fill out, I'm going to go over here so you can see it. You're going to fill out this table for the elements that are listed. So starting with hydrogen, which I've done for you, then there's lithium, there's neon, fluorine, and then the last one you get to choose one of the elements from the periodic table. So what do I mean by fill out this table? This table has the naturally occurring isotopes of that element. So for hydrogen, the naturally occurring isotopes are hydrogen 1 and hydrogen 2. You want the atomic mass of the element and the percent abundance, of the isotope, and the percent abundance of each isotope as well. So going back to your setup here, you're going to click on the symbol just so you can see the symbol. Notice that there's hydrogen 1. And abundance in nature. This tells you the percent of hydrogen 1 in nature. You also want to get the actual mass. Right now it's the mass number, which remember is the number of protons and neutrons. Since hydrogen 1 only has 1 proton, its mass number is 1. But we want the actual mass. So you want to go to atomic mass AMU. You click on that and then you're going to record the 1.00783 and the 99.9885% into the table here. You can see it goes under mass and then percent abundance. Now you're going to try it for the second isotope, and let me go back to the table. You can see the second isotope is hydrogen 2, so how do you make hydrogen 2? Well, remember the mass number is the number of protons and neutrons together. You already have 1 proton. To get hydrogen 2, you add 1 neutron. So you take your neutron from your neutron bucket, and boom, there you go. And now it gives you the actual mass of hydrogen 2 is 2.01410, and then the percent abundance is 0.0115%. And again, that information, the mass goes here, and then the percent abundance goes there. Okay? All right, so when we say Part A, we're filling out that middle table there with the mass percent and with the percent abundance, and then the actual mass of each isotope. So there you do it for lithium. Need the naturally occurring isotopes for neon, the naturally occurring isotope of fluorine, and then the last one you get to choose. So let's go over that one because that one's a little bit tricky. So there are 3 rows here, by the way, for this table. You may not need all 3 rows. Some isotopes or some elements only have like 2 naturally occurring isotopes. As you can see, fluorine has 1. The other element that has only 1 naturally occurring isotope is beryllium. You can see it's 100% abundant in nature is beryllium 9. So you're told in Part A that you cannot use beryllium, but you can use any of the other ones. So for example, we didn't do carbon. Pretty sure we didn't do carbon. Let's just double check. So we did fluorine, we did neon, we did lithium, and we did hydrogen. So yep, we didn't do carbon. So if you wanted to, you could choose carbon as another one to do. Now, when you do that, you would write down the elements. So carbon 12, and you can write down the name if you want, or the, oops, there we go. And then to write down the actual symbol, remember it's mass number goes on top. And to make it into a superscript, you highlight the text and then do Control period, and that will give you a superscript. Okay. Now for the subscript, you do Control comma, and then carbon, if you look on the periodic table, it has an atomic number of 6 or 6 protons. And then there you go. So that's how you would write that. If you wanted to, you can do one or both if you want. Okay, so carbon 12 The actual mass is 12.00000, so 5 zeros, and then the percent abundant is 98.93%. All right, so I'm going to go over here. And then 98.93. All right, so I got my information there. But that's only one isotope. And let me go ahead and label the isotope that I'm using here by putting that on top. We're doing carbon. Okay, that's the, sorry, not isotope, but the element. We're using carbon as our element. Okay, so now the question is, well, this is clearly not 100% abundant, meaning that when I gather all the elements, all the carbon atoms on Earth that occur naturally, only 98.93% will be carbon-12. So that must be some other element. And you kind of have to figure that out in a way. But a shortcut to figuring it out, and what I mean by figuring it out is like you would add a neutron, and you see, oh, if I add one neutron here, I get to carbon-13. That gives me an abundance of 1.07%, right? So I'm just going to take this information and repeat it for carbon-13. Change that there. And the mass of carbon-13 is 13.00335, and the percent abundance is 1.07. Forgot what the rest of that said. 335. All right. And then 1.07. Okay. And so then the question is, well, is this it? Is there another naturally occurring isotope? There's two ways you can figure it out. First, you can figure it out by looking at the percent abundance. If you add the two values together, and that gives you 100%, so 98.93 and 1.07, if that gives you 100%, then you're good. That's it. That means that you have all your naturally occurring isotopes because you reached your maximum percent. All of them have been accounted for. If you don't, then you would do things like either add an additional neutron and see what happens. When it says trace, that means that that's not naturally occurring, or it's not naturally occurring in any significant amount, so you can ignore it. If it says unstable, the same thing, right? This is one saying 0% in nature, so you can, instead of adding neutrons, you can also take neutrons away and sort of figure that out. Like, okay, so we're back to carbon-12. If I take away 1, bringing me down to carbon-11, is there a percentage there? So you can figure it out by playing around with the amount of neutrons and seeing if you get a percent. That's one thing to do. The other thing, and probably the easiest thing to do, is if you go to the mixtures, okay, which you're going to use in part B, but if you go to the mixtures, just to figure out if you have all of your isotopes, choose your element, again, carbon, and go to nature's mix. And when you do that, if you look at the percent composition, on this pie chart, it will show you all the naturally occurring isotopes. All right, so I noticed that I have only carbon-12 and carbon-13, so that means my percent composition has been made up. I only have these two naturally occurring isotopes. Okay, so that's how you can figure out how to fill out the last one. And thanks to the student who brought that question to my attention. All right, the other thing that I wanted to point out before I forget, some of you, I made an error in this chart. It's neon, for neon, it's neon 20, neon 21, neon 22. The names of the isotopes are correct. Remember, for the name, the number at the end is the mass number. So neon 20 tells you it has a mass number of 20. This is not the number of neutrons or the number of protons, but the number of neutrons have plus protons. But in the symbol, for some of them are incorrect. So the mass number here is correct for the first one, it's 20. But in the second one, some of you have a 20 there instead of a 21. So I just changed that to 21. Okay. And then the same thing here. This one has instead of a 22. Let me go ahead and put that parentheses in there. Okay. So now we're all set. So now we have our mass numbers all correct. In case yours is not, make sure you make that correction. Okay. That was all part A. Those were the questions I got for part A. Part B, what you're asked to do in part B now is you're going to look at nature's mix for all of the elements and then take a screenshot. So let's go back to the one we already had, which is for carbon. So all I'm going to do is, let me go back here. Let me just reset it. When you go here the first time, what you'll see is it's going to be under my mix. You want to select nature's mix. Make sure you select nature's mix, and then also select whatever element you're looking at. So hydrogen was already done for you. When you get to lithium, you click on lithium for it. And then you just take a screenshot and paste it into the table. I'm going to do carbon, which was the last one, my element I chose. I'm going to take my screenshot and then go back to my table there and insert that in here. Now, the purpose of doing the screenshot is just so you have that visual. You can see what is meant by percent abundance. So if you were to gather all the carbon atoms, if let's say these were all the carbon atoms on Earth, you would see that most of them are carbon-12, the purple ones, and only a few of them, about 1%, are carbon-13. All right, that's part B. And then after you finish doing that, inserting all the pictures in for part B, you can then go down to answer questions 1, 2, and 3. Now in question 1, some folks were asking, it says compare the percent abundance you recorded for each isotope in part A with the percent composition found in part B. Well, what do I mean by that? The percent abundance, that's the values you put in the table. So if you go back to the isotope mixture, the percent abundance were what was recorded in here for the in that pie chart. It says abundance in nature, that's your percent abundance. But when you go to mixtures, so this is for carbon-12, when you go to mixtures and you look for percent composition, that pie chart is called percent composition. What do you notice about the percentages? So if you look at carbon-12, the percent composition carbon-12 is 98.93%. And when you go over here, percent abundance, it's 98.93%. What do you notice about those two numbers? Are they the same or are they different? That's all I'm asking you to do there. So when I say part A, I'm referring to when you filled in the table. And when I say part B, I'm referring to when you copied and pasted the picture. All right, last part, part C. So for part C, use your data to calculate the average atomic mass, and you have to show your work. I showed my work here as an example. This is what your work could look like. Maybe you want to do it some other way, but you notice I'm showing which numbers I'm multiplying, I'm showing which values I'm adding, and then I'm putting my final answer with the mass AMU in there. Okay, because remember all values should have units if units are applicable. All right, so that's what you're going to do in part C, is do the calculations. And if you need help, there is a video linked at the top in the instructions to show you how to calculate the average atomic mass. After you've done that, you're going to go on to answering these questions, which will get you to reflect and think about what average atomic mass is, how do you calculate it, etc. Okay, and then you can just go ahead and submit it when you're done. If you have any questions about this, please let me know. I hope this video was helpful for you. Have a quality day.